Okay, this is section 10.3, valence bond theory. It is a theory to explain the electron pair or covalent bonds by quantum mechanics. Quantum mechanics basically is what we used in chapter 8 for the electron configuration. Okay, and so basically it has two parts. It says that a bond is formed when the orbital of one atom occupies the space as an orbital from another atom. And so this is shown here in this right here. I have the 1s of the hydrogen overlapping with the 2p of a fluorine, and so where these two overlap is the formation of a bond. And basically the other thing that it says is that total number of electrons is no more than 2, which we've been saying all along. What we're going to focus on is hybrid orbitals. Okay, they describe the combination of atomic orbitals that happen. Okay, and so basically the number of electron pairs that so when we're doing the molecular geometries, it would be the outside atoms plus the lone pairs has to equal the number of letters. So for CH4, okay, I have carbon, hydrogen, hydrogen. I don't really have space here. Hydrogen, okay. So that's 4 outside atoms, 0 lone pair. So when I add up 4 plus 0, I end up with 4. So I need 4 letters, okay. So the sp3 is S and then 1, 2, 3 P's. So there's the 3 P's, okay? So electron configuration says that I can only have one S, there's 3 S orbitals, one S orbital, there's 3 P's, and there can be up to 5 D's, but the most we ever have is 6. So the highest that we're going to see is sp3d2, which would be an example of xenon tetrafluoride, okay? For the PCl5, okay, it's phosphorus with 5 chlorines around it. So this is the electron configuration, or the Lewis structure for phosphorus. Okay, so this one would have 5 outside atoms, 0 lone pair, so that's 5. So it's S with 3 P's, 1, 2, 3, and then D, so that's 4, 5. So I write it as sp3d. This is the same as that. Okay, so let's practice. Okay, so anything that has basically these are by the families. So anything in the linear family is sp. The trigonal planar family, which is trigonal planar and bent, must be sp2. Tetrahedral, which is tetrahedral, trigonal pyramid, and bent, is sp3. The trigonal bipyramid family, which is trigonal bipyramid, seesaw, T-shaped, and linear, is sp3d. And octahedral, which is octahedral, square pyramid, and square planar, are sp3d2. So these are the families here. Not the molecular geometries. All right. So again, this is one in which I have to draw the Lewis structure for. Okay, so I have phosphorus has 5 times 1 is 5. Chlorine has 7 times the 3 gives me 21. So I have a total of 26. Phosphorus is the center with 3 chlorines around it. So minus 6. So it gives me 22, 4, 6, 8, 10, 12, 14, 16, 18. So 2 more goes on top of the phosphorus. So I have 3 outside atoms, 1 lone pair. So there's a total of 4. Okay. 3 and 1 is trigonal pyramid. Just so we practice that some more. Being trigonal pyramid, it is polar. But for this question was the hybridization. So I need 4 letters, so it's S, that's 1, and I can have up to 3 P's, so SP3, so that's 3 letters. And so this is the same thing as writing S, P, 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 but I want you to use this donation over here, okay? SICL 4, it's in green. Si has 4 valence electrons, that's one of them, so that's 4. Chloride has 7 times the 4 is 28, so it's 32 total. So Si in the center, 4 chlorines. So I used up 8, leaving me 24. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I have 4 outside atoms, 0 lone pair. So the shape or the geometry is tetrahedral. It's nonpolar. And I'm just doing these just for extra practice. But again, I have 4. And just like this one had 4, this one has 4. Anything that adds up to be 4 would be the same. It's SP3. Okay? And the last one is sulfur dioxide. So sulfur has 6 times the 1 gives me 6. Oxygen has 6 times the 2 gives me 12. So that's a total of 18. Sulfur's in the center, 2 oxygens on either side. So I used up 4, leaving me 14. 2, 4, 6, 8, 10, 12. So it leaves me 2 more, so that goes on top of the sulfur. Now, this doesn't necessarily matter for predicting the molecular geometry, the polarity, or the hybridization, but part of the question is going to be drawing the correct Lewis structure. And so this one actually has a resonance description because the sulfur only sees 6. Sulfur is a nonmetal, so I have to take in 1. It doesn't matter which one from which oxygen. I just chose the one on the left. So when I have a resonance description, just pick one. Oops, there's a double bond there. Oxygen. So I have 2 outside atoms. I have 1 lone pair. Okay, so it doesn't matter if it has a double bond or single bonds, they're treated the same. So that's 3 total. For shape-wise, 2 outside atoms, 1 lone pair is a bent. It's polar. And for the 3, that means it's an S and then P2. Okay, and that is the end of this section.